Hello everyone, it's September the 8th. Alright, let's get right into it. Let's see what we have today. Shifting letters. Okay. Must be something about string. Alright, you're given a string, lowercase letters, and integer array, shifts. Call the shift of a letter, the next letter in the alphabet wrapping around. For example, shift A equals B, shift T equals U, okay? And now for each shifts I equals X, we want to shift the first I plus 1 letters of S X times. Return the final string. I didn't understand. For each shifts I, shifting the first letter of S by 3 times, we have shifting the first 2 letters by 5 times, shifting the first 3 letters by 9 times. Huh? For each shifts I equals X, okay, we want to shift the first I plus 1 letters. I see, I plus 1 letters. So I shift 1, and then we have to shift these, and then the last one we have to shift these. Which means if we go backwards, the last one will be shifted 9 times, and this one will be shifted 9 plus 5 times, and this one will be shifted 3 plus 5 plus 9 times. So basically we're going to do a cumulative sum, but in reversed fashion, right? We do a cumulative sum, but in reversed. And after we do that, we are going to shift the first one. And the shift can be done by taking the value and then plus the number of shifts mod 26, right? Mod 26. Because a shift actually is a mod 26 or mod 25. How many times in the shift to get back? Well, if it's 25 times and 26 times, so it's mod 26. Okay, so here's my solution. Let's see how it works. ST. Alright, so C. Oh my god. Wait, what? What the hell happened? Oh, V. I pressed C. Not supposed to be C, supposed to be V. Alright, so shifting letters. Alright, what do we do? So first we're gonna reverse the shifts and we accumulate. So from Eta tools, import accumulate, right? So we're gonna say presum equals accumulate shifts. We're gonna reverse it, and we're gonna turn that into a. Oh, we don't even need to turn that into a list. We don't need to. So all we need to do now is, what do we do now? We do you do a string or you do concatenation of string? Well, do concatenation. Let's see which one's faster. It doesn't really matter. So we just say for I S, right? No, don't call it S. I shift in enumerate. We can do this, right? And then we have to have a res equals this. and then we do res plus equal to s minus I, right? It's minus I, and we need to do ord this plus 26, no, but plus 26 plus shift mod 26, and no, is mod 26, but it's still a wraparound, so it should be this plus shifts mod 26. Yeah, I think it should be this plus shift mod 26, right? Yeah, this plus shifts mod 26, and this one will be char, and then we can return a result. All right, we return res. No, return res has to reverse. All right, so let's take a look. What do we have? We have ABC and 359 return RPL. Then we have AAA 1, 2, 3. That shall return GFD. All right, so S shifts, and here is shifting letters, shifts, and S and shifts. Nope, what happened? Oh, I forgot to put this. Nope, not an arguments converted during string formatting. I think, yep, I need another one. Ah, that ain't right. That ain't right. Hold on. Shift. No. I think what we need to do is ord this, right? Ord this plus shift. No, it should be ord this minus 97, right? So that will we just put my 0 plus this, and then plus shift or mod this plus 97. How about this? We're getting closer. We're getting closer. Hold on. Let me take a look at the shift. Print shifts. Right, print shift. So first shift 9 times, and then shift 14 times, and then shift 17 times. That makes sense, right? So C shift 9 times is L, but I give you J. How? D, E, F, G, H, I, J, K, L. Oh, minus I. That's the problem. Ooh. What do we do? Well, what we can do is accumulate, right? And let's start with 0. What if we start with 1? Right? We start with 1, and then this one shall work. Yeah, start with 1, it works. All right, so I think it's possible to get it down to 1 line. So we have this item shift. We got a shift done, and oh, it's fine. Let's just do it that way. You know what? You know what? Let's do this list s, right? And we'll just say minus I equals this, right? And then we say dot join this. Nope. Oh, then we don't have to reverse again because we're already going from the back to the front. That shall work. Accumulate. Yeah, that shall work. All right, let's try it. Was any test cases? A single test case? It should be fine. Let's try it. Submit. Pending. Judging. Ooh. That was slow. That was so slow. Wow, everything is slow. Not sure if it's my laptop or my laptop is struggling. It's alright, but some people have better solutions. Alright, let's try original. Like all, what's the original? All string manipulation. See if string will make it faster. Alright, so yeah, it's all string. It's all string. Let's see if all string will make it faster. Probably not. I don't really think string will make it faster. Try it. Pending, judging. Come on. That was slow as hell. No. It's just one of the methods. So maybe this is quite naive, right? Quite naive. So we perform prefix sum backwards on shifts, then apply each shift to each letter in S. That's it. So it should be O N, right? It should be O N. Yeah, it should be O N, and we arrived at 59% ranking with. I have one more trick on my sleeve. 218 with 812 milliseconds. And when you do accumulate, right? We can. Oh, can we mod? Can we mod? If you look at it, what we do is this minus 97, right? We plus this, plus all the shifts, and if, right, when we do the accumulation, we apply the mod every single time. I have this idea. Let's try it. So this idea is, what we can do is we get the new shifts, right? So new shifts will equal to No. Let me think. It'll be the previous sum. So we always, let me think, this 0 times ln s, right? So let's say for I in range ln s minus 1, minus 1, minus 1, right? What we do is res I equals to shift I, right, equals to S I ord Si minus 97, right, plus shifts I plus shifts I, and then we are going to mod 26 again, plus 97 again. Oh, it's going to be this empty string. So this is going to be, oh, it's fine. We do it at the end. Let's do it at the end. So yeah, that's that. And I'm going to say so n equals ln s. So everything will be n, and this will be n minus 1. Let's say if I equals n minus 1, if I not equal to n minus 1, what do? We say shifts I equals shifts I plus shifts I plus 1 mod 26. So we just kind of modding it every single time. So by modding it, we avoid big numbers. So if there's no big numbers, I think can speed it up. So we do this, and then at the end, we're going to return, say join. Join what? Join, let's say, char, right? Char R for R in res. All right, let's give it a shot. Yep, the laptop is super slow. I'm not sure why. I'm not sure. I think it's faster. Let's give it a shot. Let's see if this one's faster. Then the only difference is we are modding along the way, right? And we are not doing any reversing. That's the only thing I can say. Come on. My God. I've never seen my laptop struggle this much. Yeah, the laptop is so hot, I can cook an egg on it. Alright, let's try this one. See if this one works any faster. Pending, judging. I don't think so. I think it's about the same. Yeah, it's actually slower, so no. Well, I thought by taking mod at each prefix sum can avoid large numbers and thus reducing runtime, but it turns out not so. So this means the actual solution is much better than what I have here. All right, let's just give it another thought. I mean, the good solution is what, maybe 10 times faster. Give it maybe 10 more minutes and see if we can get it. Yeah, so we're shifting, right? Shifting. The thing I can think about is bitmap. Can we use bitmap for this? Well, the S length is huge. Saying we use bitmap to find, no, but mod is already fast, right? So by the cumulative sum, we know how many times each one to shift, and I would perform a bunch of operations to determine what's the final result is. How could this be faster? Let's see, so in this case, 3, 5, 9, right? We have 9, 14, and 17. That's the total number of shifts each one needs to do. So first shift 17, the second one shift 14. That means first one will shift 3 times more than the second one, right? And the second one will shift 5 times more, and then the third one. So what we can do is we start from C, right? So C shifts 9 times, we get L. And then the left one will shift 5 times more than L. So just L plus 5. And then this will shift 3 times more than this. So we, well, maybe that's the one. L, M, N, O, P, Q. Wait. 5 times more. M, M, N, O, P. That's 4. That's 4. Huh? I shift 14 times. Let's shift 9 times, right? So we shift 9 times. This will shift 9 times. Oh, it was after shifting 9 times and then shifting 5 more times. So the current difference between the two, L and P. Well, currently, so no, C and B. So we need to get back to, so minus 1, right? So minus this plus this. Minus this plus this. Maybe that's the one to go for. Let me try it. I have a new idea. Let's try a new idea. They're all ON, but I don't know why some will be faster than the others. Mod. I think it's because of mod. Mod takes time. So first of all, res will equal to, let's just say it's going to be ord s, no, ord a for a in s, right? So we take all of this, and then we say the last one, so res minus 1 or equals what? That's a len s equals n, right? Res minus 1 equals res plus equal, right? Plus equal. So we do one mod, right? We still have to do mod every single time, but it will be a smaller mod. We're still modding, right? We still have to mod. I don't see how this one is different from this one. Let me think. And plus, we cannot get the original value because I'm changing this one. Okay, well, that one can be resolved. That one can be resolved. So what are we saying? We're saying the difference between the two, and then plus this. Right? The difference between this and this, then plus this. I don't think this is going to make any difference. Don't know. I don't think so. I think it'll be the same. Yeah, I think it'll be the same. And for I in range, right? And minus 1, minus 1, minus 1. Still have to go through, and we say res I, right? Res I will equal to equal to what? Res I plus 1, right? So I have to do the same thing. If I is equal to n minus 1, n equal to len s, if I is equal to n minus 1. Well, it's actually not equal to. Right, if it's not equal to, then res I will equal to ord si plus 1, right, minus res I. So that calculates the difference between the two. Is that how it is? Or minus 1, right? So this one will be, it should be this minus this, and a plus. So it should be plus equal to res I minus this, right? So res I, we apply this difference, and then res I plus equal to shift I, shift I, and say res I plus shift I. Now res I would have to minus 97 plus shift I, and then mod 26 plus 97, and then return this. Isn't this the same? Like, how is this different from the other solutions? Looks exactly the same to me. And it's actually not correct. LF. How is F? Si plus 1, that is C. Res I is the B, so B minus C shall be minus 1. So we say res I, so B minus 1. No. That's the original difference. It's not. It's the, hold on. It's the difference, right? The current is the original difference, So we can say res I, this is the original difference. And then what we're going to do is res I. Ooh. Huh. No, it's the same thing. I don't think there's any difference. Let's say this. Let's just finish this code. Let's just finish this coding. It's gonna be plus 1, right? Plus this minus this, which means we're gonna combine the two. But anyway, so this res I equal to res I plus minus 97 plus shift I mod 26 plus 97, and then else. Else it will just be this plus this, which is the difference. Yeah, so this plus this is the difference between front and back, and then we apply the difference, the current one, and we add the shift as additional shift, and then mod this plus 97. Okay, so and then when res I is used, we have to add 97. So how about now? Pass. Oh, but it's slow. It's even slower. I cannot judge by my laptop. Let's try this one. But it's the same idea. It's the same logic. We're just trying to play different varieties of doing it. But no, that's not right. All right, I'm out of ideas. Let's see. Why it was so fast with other people? There's one possibility that I can think of. Hopefully it's not that. Well, the possibility is the question's old, and all those fast methods, they were from a long time ago when the test cases are fewer. That's one possibility. Yeah, this one's not going to be fast. No, this one's not fast at all. So string manipulation is the fastest, and this one is ON, and then I don't know. Prefix sum. Okay, I think this is the same as my idea. All right, hold on. Wow. 848. So this is LeetCode 848. it's deteriorating performance so much. There got to be a way to fix this. All right. So we sum all the shifts, mod 26. And this append this plus this, x equals minus shifts. That's the same idea. That's the same idea as I have. Yeah, I think we did get it. I mean, if you look at the submission, I mean, those good times probably is when I have fewer test cases. That's the only thing I can think of. Because the difference in time is just tremendous. And also because we have 2 peaks, right? 2 peaks usually means either you have 2 distinct solutions. Now we only have 1. So the only possible explanation for the 2 peaks is these are done with a different test case. Wow, 188. My God, the speed. Yeah, it's the same idea as the prefix sum, and then this minus this plus this, and then this. Yep, that's the same thing. All right, nothing more to see, I guess. Nothing more to see. I did develop like different varieties, right? It's a different varieties of the same method. It turns out the fastest is this because I'm not. Yeah, this is slow because I did this part. And this is to avoid large numbers. Doesn't really work. String manipulation directly is always the fastest. That's what I found. Not medium. Yeah, it's pretty simple, I guess. Good for morale. Two lines using accumulate. So we list this and then enumerate this to this. Yeah. That might be. I mean, technically, you don't even need to have I mean, technically, I think 1 line is also sufficient. Let's try 1 line in this. Challenge accepted. All right, so let's try to do it 1 line. I was thinking about it earlier, so 1-liner. Basically, what we're gonna do is we're gonna reverse this. Ooh, hold on. Now we have to go from the back to the front, right? We have to go back to the front. So we accumulate, and we do this. We enumerate, right? And then what we do is we just put this. Then we use okay. Yeah. Let's do this. So we do this. Put it here, right? For this, and then we're going to say return join. Yep. So that'll be 1 line. 4. Oh, that's why we need to reverse it. which means let's join, that's reversed, right? Reversed. No, it's not reversible. Generator is not reversible. Okay, so don't reverse here, and we reverse at the end. Right? So we join this and then reverse at the end. Let's see. I don't think it will give me good results, but it'll be fun. Technically, this can be done in one line. Oh, wow, whatever happened to the laptop? So slow. All right, let's see. How fast can you go? Submit. Why is it so? Which thing is taking all the GPU? Oh, there's all the CPU. OBS is taking a lot. Kernel task is taking a lot. No. Oh, it's all right. It's all right. It's all right. So I just want to know that it passed, so I can post this. You know what? It's actually because this dude is famous, right? So it's more likely that my code will get exposed if I post it as a comment under his post. Just tagging along. This is like a magnet, so people will be able to see this more often compared to if I want to post this as my like my solution. Anyway, all right, that will be it. That will be it. Lots of struggle with the laptop. Not the internet. It's just the laptop is slow. Yeah, something is off.